in this lesson, we're going to go over inscribed angle theorems. We have an inscribed angle is going to be an angle that has its vertex on the circle and its sides are going to contain chords of the circle. So we're going to name an inscribed angle based off this picture. So once again, we want to find an angle that has a vertex on the side of a circle. That's going to be right here where that point B is. And then we are going to use the two chords from that point. So here and then over here to that point A. This is an inscribed angle, so we can name it as angle ABD. And then we're going to name a central angle, which this is going to bring back some old information that we've talked about in the past. But remember, a central angle has its vertex at the center. So the center here is C, and it should be formed by using a radius on either side to then have our endpoints on the circle. So here, my central angle is going to be ACE. Okay, now let's go over some inscribed angle theorems. So we have if an angle is inscribed in a circle, then the measure of your angle is going to be equal to 1/2 the measure of the intercepted arc. Okay, so remember, intercepted arc is just going to be the arc that is formed when you have the two endpoints, not the vertex, the two endpoints of the angle. All right, so here we have the measure of angle B. Okay, so to clarify, angle B here is going to be an inscribed angle, because if we notice, its vertex is on the circle, so right there where B is. That angle is going to be equal to 1/2 the measure of our arc AC. Okay, and we know it's going to be that arc AC because that's where our intercepted arc is. Okay, our two endpoints of that angle, and then everything in between them. All right, and then we have here that the measure of angle ABC is going to intercept, and it's just going to be that arc AC that we had mentioned. Okay, so then we're just giving an example here that if the measure of my arc AC is 100 degrees, okay, so here if we know that this is 100 degrees, then in order to find the measure of the angle, the inscribed angle here, ABC, we would just take half of that. So we would take 1/2 of that 100 to get 50 degrees. Okay, and now I'm going to erase that just because when we come up with this next one, we're going to just use something different. They gave us a different number to deal with. Okay, so here in my next bullet point, we have if the measure of angle ACB is equal to 70 degrees. So if the inscribed angle is 70 degrees, and we want to find the measure of our arc, that intercepted arc AC, then what we need to do is we need to double the angle, okay, double that inscribed angle to then get the arc measure. So my arc measure would be 140 degrees. Okay, and then down here, we are just kind of building off of that. So we have if two inscribed angles of a circle or even congruent circles are going to intercept congruent arcs or even the same arc, then the angles are going to be congruent. Okay, so let's look at some examples here. we have in this first picture that angle 1 is going to intercept what arc? Okay, so if I look at this angle 1, I'm going to highlight it. Okay, my endpoints are going to be D to C. So that's going to be the arc that we're going to intercept. Then looking at my angle 2, that is going to intercept. And we'll notice here that using those endpoints, we have the same intercepted arc from C all the way to D. So what can we come up with from that? Well, because they intercept the same arc, we know that the measure of angle 1 is just going to be equal to the measure of our angle 2. Okay, and now let's just apply a little bit more to that. Here we have that angle 3. We want to know what arc is it intercepting. So angle 3 is going to be intercepting arc. We would have A all the way to B, so arc AB. And angle 4 is intercepting. We would have arc CD using our endpoints. All right, so we're trying to come up with some information from that. Well, unlike in the previous one where my two angles intercepted the same arc, here I do have two different arcs, but what I do notice about the two arcs is going to be the fact that they're going to be congruent. So arc AB and arc CD are equal to each other. So we are able to say that the measure of angle 3 is going to be equal to the measure of angle 4 since their intercepted arcs are congruent. You could also say that they are congruent as well. All right, another kind of build off of that theorem, we are going to have here that if an inscribed angle of a circle intercepts a semicircle, so half a circle, then the angle is going to be a right angle. And this goes into exactly kind of what we had said earlier. And so because if I look here at this inscribed angle, I notice that my endpoints are going to be B and C. Okay, so everything in between them, we would take half the measure of that arc to get that angle A. Well, since I noticed that this is a diameter, okay, and I know it's a diameter because it does have the center that it's going through with two endpoints on the circle, then I know that this is going to be 180 degrees. Well, half of 180 degrees is giving me 90 degrees, and that's how we are able to say that this is going to be a right angle. Okay, moving into our next one, we have the opposite angles of a quadrilateral that is inscribed in a circle are going to be supplementary. So remember, that means that they're going to add up to 180. Okay, and so here we're looking at it, like they said, opposite angles, so they should be across from each other. So angle R and angle N are going to add up to 180. And angle A and angle G are going to add up to 180. So this is a little bit different than what we've been talking about with our quadrilaterals, but that's because this isn't specific to parallelograms or anything like that. But let me explain a little bit of why this is happening. Okay, so here, when we look at the fact that this angle is opening up, it's an inscribed angle with an arc, intercepted arc of R, G all the way to N. Okay. Well, I don't know how much of the circle it is the arc RGN. And then if I look over here at the opposite angle, okay, and its intercepted arc, I would start at that R, go to A, then to N. You'll notice that with those two inscribed angles, we have now, in a sense, outlined the entire circle. Well, we know an entire circle is 360 degrees, and since these are inscribed angles, half of 360 degrees is 180. And so that's where we're getting that these opposite angles are going to add up to 180. All right, last thing we have is one more theorem that is stating that the measure of an angle formed by a tangent and a chord is just going to be half the measure of the intercepted arc. Okay, so here, when we look at our chord and our tangent, okay, this angle is just going to be half the measure of that arc BDC. Okay, so starting at this endpoint and then just all the way until that tangent line touches the circle. Same idea over here. Okay, so if we look at our tangent line and our chord and where they intersect, this angle is just going to be equal to half the measure of that arc that is being intercepted, and that's going to be from B to D, and then all the way once again to C, where that point of tangency is. All right, now let's look at some practice problems where we can solve. Okay, so we have use the figure to the right to answer the following. We're going to name an inscribed angle in this picture. Okay, so looking for an angle that has its vertex on the circle. Well, we have two vertex on the circle. We have right here where that A is, or even where that B is. We are looking for it to be created by two chords. Okay, so here we have a line that's going to have two endpoints on the circle. And the only other one that's going to have the two endpoints on the circle is going to be that AC, that diameter. And so my inscribed angle here is going to be CAB. Okay. Now we have name an arc intercepted by the angle BAC. Okay, so looking at angle, we got BAC, so the inscribed angle we just came up with. Our intercepted arc, okay, is going to be from those two endpoints and everything in between. And so that would be either arc BC or arc CB. And last one for this problem, we have if the measure of our angle BPC is 42 degrees. Okay, so BPC is 42 degrees. They have that labeled. That's going to be this angle here. Find the measure of my angle BAC. Okay, so looking at it, that would be BAC, this inscribed angle here. Well, just talking about a few things, we have that angle BPC is a central angle. I know that because its vertex is on the center, and therefore this arc here is equal to it. So the arc BC has a measure of 42 degrees. And so to find that inscribed angle's measure, I'm just going to take half of that 42. So 1/2 of 42 is going to leave me with 21 degrees. Measure of angle BAC is equal to 21 degrees. All right, now let's look at number 2. Okay, and for number 2, we're asked to find x. Well, what we currently know is that from K all the way to L, this arc has a measure of 100 degrees. What's also very helpful here is going to be the fact that we do have a diameter. And once again, I know this is a diameter because it does go through the center with 2 endpoints on the circle. So that means that that whole side over here is 180 degrees. And that means that this whole side from J all the way to that K, so arc JLK should be 180. And since we know that this portion of it is 100, we can subtract. So that will leave me with 80 for that intercepted arc. And then to find that x, okay, that inscribed angles measure, then we are going to just take 1/2 of 80 to get 40. So x is going to be equal to 40 degrees for this problem. All right, now let's move into number 3. Okay, so for number 3 here, we have find the measure of angle. We've got BRT, okay, and we are going to find the measure of angle TR and then S. All right, so what do we know so far? Well, so far we know that this angle here is going to have a measure of 126 degrees, okay? And you can use your vertical angles because we still are going to have that they're congruent in a, even in a circle. So this will be 126 degrees as well. And since we do have a diameter, okay, being formed here, we know that that whole side is going to be 180 degrees. So I'm going to start off by subtracting that 126 from 180. And I'm going to be left with 54 for this angle here. Okay, well, since that is a central angle, once again, remember your arc measure is congruent to a central angle. And so the arc T to R is also 54 degrees. And so in order for me to find the measure of my angle, we got BRT. I'm going to take half of that arc, that 54, and I'm going to be left with 27 degrees. So the measure of my angle BRT is 27 degrees. Okay, now let's go in and find that purple angle that we have. Okay, that was our angle TRS. Okay, well, what's going to help me here is going to be the fact that once again, we do have that central angle of TAS is 126. So that means that this intercepted arc is also 126, which if you can't tell, okay, I'm going to outline it with my little laser. We have that T angle TRS, okay, is going to be using that intercepted arc of 126 degrees. So we're going to take half of that to find my answer. So we'll get that the measure of angle TRS is going to be 63 degrees. Okay, so let's move into number 4. Okay, number 4 does have quite a bit to it. So in circle Z, we are given that line or segment, AB is parallel to segment DC. Okay, so I'm going to start off with marking that. Then we also know that the measure of our arc BC is 94 degrees. And that the measure of angle AZB, so A to Z to B, that's going to be this central angle here, is 104 degrees. While I'm at it, since that is a central angle, I'm going to go ahead and mark my arc measure as at 104 degrees as well. All right, we're going to start off by finding the measure of our arc AB. Well, I went ahead and I jumped the gun, and that is exactly what I was asked for. So my answer there is just going to be that 104 degrees from A to B here and everything in between. Because like I mentioned earlier, that was a central angle that was given to us. And so therefore arc measure and central angle measures are congruent. Okay. Then moving into my measure of angle backtrack. Measure of angle BAC. Sorry about that once again. We got B to A and then to C. Okay, so that is going to be an inscribed angle. And since it is an inscribed angle, we're going to look at its intercepted arc. So from my endpoints B all the way to C, we want to take half of that arc measure, so half of 94. Which is going to give you 47 degrees. Okay, moving into our next one, we have the measure of angle ADB. So starting at A, we're going to D, and then over to B. Okay, so looking at that endpoint on my circle, we've got from A to B, and then everything in between, that's going to be using that 104 that I had mentioned earlier. And so since this is an inscribed angle, it's not congruent, we are going to need to take half of it to get 52 degrees. All right, now let's move into the measure of our arc AD. Okay, so we're going to try and find the measure of arc A all the way to D. Okay, and we're probably going to just need to look and see what kind of angles are going to be formed from that. And so I'm going to look at that A, well, and D. I'm looking like I'm going to be having this angle here being formed. That's an inscribed angle. And so I need to know what is the measure of this angle here, because I'm not given it. But they gave us parallel lines for a reason. So if I look at my parallel lines, okay, I notice that I do have alternate interior angles being formed. And therefore, I can say that the measure of arc AD is going to be that same 94 degrees because of alternate interior angles. Then to find the measure of arc, we got CD. Okay, so for arc CD, here, we pretty much have the entire circle, because remember over here we said this was 94 degrees. So what we can do is we can take everything and subtract from 360 to see what we're left with. Okay, and so when you take that 360 minus 104, minus 94, and minus another 94, you are going to be left with 68 as your answer. So the measure of that arc should be 68 degrees. Okay, now let's look at finding the measure of angle DAC. Okay, so starting at D, going to A, and then C here, we have that inscribed angle being formed with the intercepted arc of DC. So we're going to take half of that 68 degrees to find the measure of that angle. Which will leave you with 34 degrees. All right, and lastly, we have the measure of angle AEB. So starting at A, we have E, and then B. So what I like to do with this one here is, because it's not a central angle and it's not an inscribed angle, I'm going to focus in on the fact that I do have this lovely triangle being formed here. And this angle here we know is going to be half of that 94. And same over here, we're going to have half of that 94 for this intercepted arc. And so we have that this angle is going to be 47 degrees that we found earlier, and same with this one. And so I'm going to find this angle by using the triangle and subtracting those two angles from 180, and you should be left with 86 degrees. Okay, now let's flip it over to the back side. We have 3 more problems to look at. So for number 5, we have quadrilateral QRST is inscribed in the circle C. We are given here that the measure of our angle T is 95 degrees. S is going to be 100 degrees. And we want to find the measure of angle Q and R. Okay, so to find the measure of angle Q, okay, I'm going to start off, because remember your opposite angles are supplementary, and I'm going to subtract the opposite angle of 100 from 180, and I'm left with 80 for the measure of angle Q. Then we're going to apply that same concept to finding the measure of angle R. I'm going to take 180 minus its opposite angle, that 95. And you're going to be left with 85 degrees. Okay, moving into number 6. Number 6, we have in circle A, we have that the arc PQ is congruent to arc RS. Okay, so I'm going to mark them as being congruent. Then we have that the measure of angle 1 is going to be 38 degrees. And that the measure of arc QR is 28 degrees. All right, so let's see what we're asked to find. So we're going to start off with the measure of angle T. So here, that's going to be a pretty easy one. When I outline that angle here, you'll notice that we have the endpoints along a diameter. And so this is just going to be 90 degrees because half of 180 gives you that 90. Okay, moving into angle 2. Well, angle 2, if you focus in on the fact that we do have this lovely right triangle being formed, we know that angle 1 is 38, that angle T is 90, and so we can focus in on the fact that my sum of my 3 angles in a triangle is 180, and I could subtract those 2 angles from 180 to see what I'm left with. So that's what I'm going to do. I'm going to take 180 minus 90 minus 38 is going to leave me with 52 degrees. Okay, moving into the measure of angle 3. So for my measure of angle 3, okay, I'm going to outline that real quick and see what we have. Well, I see that it is going to have the intercepted arc that is congruent to that arc RS. And I do know that QR is 28 degrees. So since we had that this was going to be a diameter here, that P to S, I'm going to take 180. I'm going to subtract the 28 that I currently know on that side. And I'm going to be left with 152. Then I'm going to divide that by 2 because the 2 leftover arcs are congruent. So 152 divided by 2 is going to leave me with 76 degrees for those arc measures. And since I am finding an inscribed angle, I need to take half of that arc measure. So 1/2 of 76 degrees is going to leave me with 38 degrees. Okay, and then if I look over here, okay, I can see that the measure of angle 4 is opening up to that intercepted arc of RS, which is 76 as well. And so it's going to be congruent to the measure of angle 3. All right, the last one for this section here, we have the measure of arc PQ. All right, well, the measure of arc PQ is that 76 degrees that I had found already. So I'm just going to write that for that answer. All right, and now let's move into our last one, number 7. So in circle Q, we are given that the measure of arc CD is 68 degrees. Okay, and that the measure of arc BE is going to be 96 degrees. So BE, I'm going to draw this out a little bit like this, just because it's not directly between 2 points. So I'm going to say that that is going to be my 96 degrees. Okay. So with that being said, okay, I'm trying to find the measure of angle ABC. So let's start off with the measure of angle ABC. So starting at A to B and then to C, we notice that my endpoints are along a diameter. AC is a diameter, since we have that going through my center Q. And so this is just going to be 90 degrees. Then we have that the measure of angle BDE is what we're trying to find. So starting at B to D and then over here to E. All right, so with that one, our endpoints are going to be along that arc that we know to be 96 degrees. And so we're going to take half of that 96 since it's an inscribed angle. And we are going to be left with 48 degrees. Okay. Then we have the measure of angle CED. Starting at C, going towards E, and then D. That is another inscribed angle that's going to have our endpoints along that arc that is 68 degrees. So I'm going to take half of 68 degrees. And I'll be left with 34 degrees for my answer. All right, and lastly, we are asked to find the measure of arc AD. Okay, so here I'm going to find from A all the way to D, this arc here. Okay, and if I notice, it is going to be using the intercepted arc from A, B, D, that angle there. So if I find that angle, I can then double its measure to find that intercepted arc. Okay, and so let's see what we can do. Well, if I look at the fact that I do have that right angle here, okay, and then I notice that my intercepted arc from C to B to D, okay, this inscribed angle here could be found using half of that 68 degrees. So that's that 34 degrees that we found earlier for the measure of angle CED. Okay. I can then use subtraction to figure out how much is going to be left for this angle here. That is the inscribed angle for the arc that I'm trying to find. So let's take 90 minus my 34. And I'm going to be left with 56 degrees for this inscribed angle. Okay, and then remember, if your inscribed angle is 56 degrees, in order for us to find the measure of that arc, I need to double it. Okay, so here I would just take 2 times that 56 degrees, and I'm going to be left with 112 degrees for the measure of that arc. All right, so now we are finished. I just want to kind of reiterate a few things when it comes to these types of problems. As you kind of saw in these last few that we've been doing, it's like a little puzzle, just trying to take it piece by piece, finding out what you can use to kind of help you build towards what you're looking for. And just keep in mind, you can use your central angles that are congruent to arc measures, your inscribed angles, which are half the arc measure. And you can even use the sum of the angles in a triangle being 180 degrees to kind of help you find what you're looking for.